So Star Wars or Star Trek?
Oh, Star Trek. Star
Oh,
Trek. Not even a competition.
Haha, there we go.
I always
Nice.
think there's not a wrong answer to that until someone says Star Trek, and then I'm immediately like, "What? What? Oh, Star Trek."
Yeah.
What about Doctor Who? Is that like a natural thing for Americans who like Star Trek to watch Doctor Who? Is that like in the same? No.
Yeah. Yes and no. There are a lot of people who I think go to Doctor Who from Star Trek. It does have a very different feel.
Yeah.
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 If Star Trek, if the Next Generation seasons 1 through 3 don't resonate with you, Doctor Who is going to be a tough. The
Yeah.
budget doesn't kick in until like season 7 on Doctor Who, so those first couple of seasons aren't gonna work for you.
That's a good comparison.
Yeah, the Doctor Who lack of budget thing was, I assume, the appeal for people who like Doctor Who. Is it not?
Yes.
Were you guys like waiting for them to get a budget where the walls stop sort of shaking?
I was gonna say, I don't mind, like, I think 11, Matt Smith is my favorite Doctor, but I don't think that has to do with the fact that they got a budget, but it does help that they got a budget around halfway through Matt Smith's season. I do appreciate that, so Torchwood, the Doctor Who spin-off series, that, like, somehow even got less budget for a while, and then they tried to it moved to Stars or whatever US channel that it moved to, and it suddenly got budget, and it also suddenly got not necessarily better.
Torchwood is a Doctor Who spin-off. I had no idea.
You had no idea that's where Captain Jack is from?
No, I mean I've never watched Torchwood, but I've seen it flash by.
Okay, all
I just
right.
never made the connection.
I think it depends on if you like the campy aspect, right? Some people do,
Right.
right? That's the
Yeah.
appeal.
I didn't even know the premise of Doctor Who until about maybe 6 or 7 years ago, which is shameful being a Brit, right? One of my older boys was telling me like he's a Time Lord. I was like, "What are you talking about?" He's like a dude who has a time machine. He's like, "No, no, no. He's like a Time Lord." And then I started reading. I was like, "Wow, okay. So he's not just some random guy traveling around in a police box."
No, they definitely like that is absolutely it's like they turned Sesame Street into like a deep canon and lore, and they were suddenly like, and Oscar the Grouch has this dark back, like originally Doctor Who was like an educational kids show, and they just needed this guy who could take you through time travel, and then I think it's because the actor like started to age out, and they were like, well, what are we gonna do to not have a Darren situation like Bewitched and freak the kids out? And they were like, oh, okay, this is what we'll do, and they turned it into a whole thing, and over time they kept doing that.
I will say Dalek, is that right? Exterminate.
Yeah,
They
Yep.
were petrifying to British kids.
Really?
I can imagine that.
It-
Yeah,
it- they were a pretty good bad guy.
sure.
Hmm.
Creepy robot. It's gonna come murder your entire planet.
With the
Yes,
toilet
but-
plunger on the front.
Yeah, the design of it makes it hard, right?
Yeah.
But yeah, it was like, how do I get away from a Dalek? Go upstairs, right?
Welcome to Acceptance Criteria, where we talk about the good, the bad, and the ugly of how software gets made and how we can all do a better job together. My name is Kevin Thomas Euland, and across the chat from me is Andrew Greener. Say hi, Andrew.
Hi, Andrew. We're also here to get deeper on the human element. I could go on for an eternity about people and how they think about the process of building complex systems. And I can't think of three better people to do that than Kevin, myself, and David. I had to
You
do it
stole
again.
my
right?
line.
I have to do it again, right? I felt weird halfway through because I'm like, there's not two of us. So,
No,
all right,
that's my
let me do that
line.
last sentence again.
All right.
And I can't think of two better people to do that than Kevin and I.
Except this week, there's 3 of us. We're joined by David Scripka, a David scientist. We're joined by David Scripka, a data scientist at a large consulting firm that will remain nameless. Say hi, David.
Hi, David.
Amazing.
Also, I'm actually no longer at a large consulting firm, but that may or may not be important.
No, that's awesome. We haven't caught up in forever. Where are you now?
So I'm at a company that does customer service mostly.
So he can talk about the large consulting group now. Perfect.
Yep.
There you
I
go.
can talk about, but well,
Yeah, exactly. No, no, no. In this first episode of a two-part series, we'll be chatting with David about the world of data science, machine learning, and artificial intelligence, and exploring the fundamentals of what data scientists do and how machine learning works. We also touch on the speed of evolution of the large language models like ChatGPT and how they're starting to replace older methods entirely. And then next week, we'll be digging into how the role of data scientists is expanding as low-code, no-code, and other tools make working with these machine learning models easier, as well as how important the collaboration between data science, product management, and engineering is becoming. And of course, Greener waxes poetic about the AI utopia of his future. But first, a friendly reminder that we're always interested in hearing questions directly from you, our listeners, for our segment User Stories. If you've got a scenario you'd like help with, whether it's working with an engineering or product team member, trying to figure out how to solve an agile process problem, or you just can't understand why your favorite app updated everything and it's now terrible, we're here to talk it through with you. You can send those questions to acceptancepod@gmail.com or submit them on the Discord and the User Stories channel, and we might be able to help on a future episode. And we're happy to keep it anonymous so no one can trace it back to you if you end up talking to a coworker or something.
I'm very excited to have a data scientist in the house. Actually, is that correct, David? Are you a data scientist? Is that
yeah, that's what I would call myself, for lack of a better term. Like most of my day to
okay?
day is programming, like software development, but I'm not like an actual software developer. I just pretend. So I'll stick with data scientist.
When you
Nice.
go to cookouts, do you tell people like I'm a scientist and then you drop the data in later?
That's a good question. Come to think of it, usually I just say I'm a developer because the data
Yeah.
science thing is hard to explain.
Oh, that's very modest. That's modest.
No, it's like no one knows what a product manager does. I just say I work with a software team. Like it's no one understands, so I just generalize.
Yeah, I say chief architect, and immediately people start talking about cantilever buildings and bridges and stuff. I'm like, nah, nope, none of that.
Nope,
Not at all.
not how that works. But before we get to all of that, let's take a short break and we'll be right back. All right, welcome back. This is a segment we like to call Personas, where we talk about the types of roles you'll encounter in the software development world and how those roles work best and you can work with them more effectively. So today we'll be digging into the role of the data scientist. So I think, I don't know, Greener, we've got some questions up here because I'll admit I think I understand data science at a high level. I think I understand machine learning at a high level, but I don't know that I've actually thought who does what types of jobs. Like there is data scientist kind of actually feels like product manager as a job title. Like it depends on the company you're in, what you're doing. And to your comment earlier, are you mostly a programmer? Are you mostly like a business analyst? Are you writing entire models from scratch? So yeah, I'm sort of curious, David, do you have like an overarching definition? Do you think it's really 4 different jobs?
It's a great question. I think it's changing a lot. And it's never really been one thing, even since it started, right? Maybe the closest thing it was when it first became a defined term was more of a business analyst, maybe someone who worked a lot with, SQL databases, doing something between a business analyst and maybe a database administrator to a certain extent. But
Hmm.
it's moved around. To your point, I think a lot of data scientists now are product managers, right? They're not doing as much direct work with the data. Maybe they're not doing as much development. A lot of data scientists, especially now with generative AI being what it is, they're not even training models that much anymore. So the connection to machine learning gets kind of tenuous. So I think it really depends on the company. Yeah. What is that particular role in that company? What are you actually doing? I think it can be a whole range of different things.
Yeah, so I'm trying to break down. Like I feel like there is that business analyst world where you are taking just existing models and you need to have well, do you need to have like the statistical math, like the background to understand I am going to look at a million rows of client data, run it through some kind of model to get answers. There's some kind of Python modeling skills there, maybe there's now low code, no code. Like what does that side of it look like?
Yeah, that's a good point. So it does help to have that background. I think just understanding some of the statistics and being able to go in and actually do the development, doing the data analysis when you need to, whether it's like a prerequisite for a skill that you have to have or something you just learn to do, that's probably a little bit different. Speaking as someone who never learned formally to code, but now that's a lot of what I do, although it's only in Python. So I'm not a real software developer. I'm sure a lot of people would say, and I would agree agree with them to a certain extent.
Every Python developer just turned off the
Oh
podcast right
no,
now.
I ruined that segment of your listeners. But yeah, I think it does help.
So then when you and I worked together, there was it was like you were using frameworks, and some of those frameworks had machine learning model. I don't know what the right word is. Like they had templates. Like you were using like a BERT model, which is a type of template of a model to do a thing, but you still had to take client A's data and run it through that model, and then you were creating a new model.
Mhm.
It was never, I don't know what the right terminology is, but you were like taking a transformer model and creating the client A transformer
Yeah.
model. So yeah, that distinction isn't totally clear to me either.
So that's a good example of for the companies that are still doing this, and there's a lot of them, right? That's more traditional machine learning. We're using fancy words like transformer models, which in theory are the same thing as the GPTs and the Bards and the Geminis out there as well, but they're a much smaller, more application specific version of the model. And so
Sure.
that still exists. You're taking a model, a machine learning model, you're training it on some data to do some specific thing. I think there's a lot of that work that's still out there. Sometimes it's called ML engineer instead of data scientist. But again, I've seen these terms used interchangeably.
And in that situation, like just to get pedantic on terminology, is there a difference between when you train that transformer model on client A and then legally you're not allowed to also use that to train on client B's data? So you have to create a copy of it for client B. Like, are those both models? Are those both data sets? Like, what's the actual output of that training process?
I think the output in that sense is a model, right? It's a
Okay.
thing trained to do a task. But to your point, I mean, and this ties in nicely to all of the current uncertainty with generative AI. The data used to train a model is kind of inseparable in some sense from the model, both practically, right? You get the model from the data, but then also legally, right? What happens if the data you trained the model on has some restrictions that you weren't aware of, or maybe you didn't want to be aware of them at the time of
Right.
training?
So what is that upper, so somebody has to go and create a new thing called a BERT model. That is some kind of crazy engineering that goes into programming the underlying concept. What is that like that's also a model, that underlying like template that you run the data through? Somebody has to come up with a new flavor of that thing too, right?
It depends. I think on what you're trying to do with the model. So I don't know. Let's say you're a social media company, kind of a weird position to be in. You have some really tricky problems that you have to deal with.
Right.
Some intersections with other parts of society that make things really challenging. But you're trying to develop a model that, I don't know, classifies user messages in some way or another. That happens a lot, right? A ton of the machine learning work at these companies goes towards tasks like that. So in one sense, you're doing a fairly well-defined task. And if you're taking a model, like a BERT model, which originally came from Google, but now it's open source, so anyone can use it to some extent. The structure of that model is already defined, right? You know what you need it to do. You're putting some kind of label on this message. You don't have to do too much as far as like changing how the model itself is working. It's mostly about, can you get the right data into the model? Can you train it? Does it have the right performance that you need for whatever your application is? And so in that sense, this is where, to your point earlier, we're starting to see some low code, no code approaches that can do this, right? Because it's really just about defining your task, which is more of like a business and organizational question. And then once you have that defined and everyone's agreed, then you can train the model.
I feel like you and I did some evaluation of like Azure versus AWS and stuff like that, seeing those kind of low code, just like tell me what you want it to do and what data set are you going to point to it. And it just knew that's always why you use model type X. And I know exactly what input and output to give you.
Yeah, and there's a lot of that. So SageMaker with AWS, that's a big platform that offers a lot of these services. ML Studio with Azure, it's the same thing.
So then, whether it's performance, whether it's because you don't want to do one label, you want to do three labels, who is the person who's doing that, even if they were the ML engineer days where they were doing more complex versions of that? Who's the person who's going to come up with BERT 2.0 or BERT version X because I want the multiple labels and a slightly more performant blah blah blah?
Yeah.
Is that a data scientist or an ML engineer, or is that someone else? Is that someone writing like C++ code or something weird?
Yeah, it's a good question. And a lot of that I think has changed in just the past couple of years. So probably 4 years ago, 5 years ago, Data scientists were doing that to a certain extent. ML engineers were doing a lot of it. Sometimes you even have ML researchers, right, who their focus is just doing exactly that. They're just researching new model architectures and new ways to think about building models that can perform these tasks. With generative AI, I'm not really sure where all of this is going, right? Because
Sure.
for better or for worse, the industry has kind of found one type of model, and they're all very similar, right? The architectures have differences, of course, but they're remarkably similar across companies and sizes and applications. And this one type of model seems to work well for a lot of different things. And so, especially at like smaller companies or maybe non-tech companies, I don't think there is as many people doing like that fundamental work on trying to figure out new model architectures.
Interesting.
But this is, pure conjecture.
No, I think I definitely, as I've been trying to read up on ChatGPT 4 versus what they want to do with 5 and things like that, and as they start to get it into, it's using, like for now, it's secretly using, I think, DALL-E to do all of the image stuff and then trying to all return it as a single data set. But I feel like you and I ran into some, like maybe I wasn't understanding the differences of like a computer vision model seemed like a completely different world than the language models that we were doing. And so is that part of the change? Have they found a similar template, or is images still different, but text is all now coalescing around a single thing?
Yeah, it's a good question. I think in a lot of ways, text is still the main modality for a lot of this, just because in many cases it's the most useful one, right? Most of the data that people have is in text or can be put into some kind of text format. But in the last year and a half or so, vision has become kind of a blurred line as well, because you have vision capabilities in GPT-4, right? You have vision capabilities in Gemini from Google. Same thing with the models from Anthropic. Their latest Claude 3 models, right? They have vision capabilities. You can feed them text or you can feed them images. And even in certain versions of the Gemini model from Google, you can feed in audio and video. So it's all going into the same type of model now. And so for certain applications, right, if you're doing self-driving cars, obviously that's a different computer vision application, and so
Right.
you're not feeding all that into GPT-4, hopefully.
Well, you never know. Elon doesn't strike me as the sharpest tool in the shed, so you never know.
That's true. There's no telling what that team is doing. But yeah, for a lot of more general applications, especially corporate application,
Right.
right, enterprise type stuff, now your computer vision tasks and your text tasks, in theory, are just one model.
Sure. Well, and I feel like there was definitely a point at which, was it Ellen maybe, who was trying to figure out, like, isn't audio just transcribe the audio to text and then it's just text at that point? So, like, there are a bunch of those that, to your point, it just always ends up as text. Video and image probably is the one. It's not quite that way, but is it to the point that, like, how good are these models getting? Because I feel like one of the things we ran into was there was, like, some company in Europe that was like, we want you to take our security camera footage and notice cracks in the wall. And we were trying to figure out, like, what are we going to do? Draw cracks onto sample training images? Are these vision models getting smart enough that we could have just run those through the ChatGPT 4 and said, point out the images that we just gave you that have, broken pieces? Like, how far has that gotten, do you think?
It's getting pretty far. Whether that particular application, is good enough for a healthcare application, for example,
Sure.
you're obviously going to have a really high bar that you want to hit. So maybe the performance is actually pretty good in GPT-4. I think in general, I'm pretty consistently surprised of just how capable it is for different tasks. But yeah, that's a great point. In other cases, it'll be really good, but you don't need something really good. You need something that's just about perfect, right, for the application. I think, and then you're still figuring out, okay, do we need to train our own model? Do we need to fine tune, right, a version of GPT, which you can pay for as well? Yeah.
Sure. Yikes. I think it was a couple of weeks ago that we talked about there was a startup that was trying to diagnose STIs by visually inspecting photos of your junk. And I
Yeah.
was like, that was probably some training of data that was questionable.
Yeah.
All right, let's do like a machine learning data science 101.
So my understanding of a data scientist would be that they are viewing the data as the product, right? The quality of that data, the story that they're trying to tell with that data. So they're really focused on the processes of how we potentially acquire that data from data engineering or some data science engineering team that's acquired that data. So now we're massaging it, we're looking at the qualities of it, and then we start to build the product out of it to say, here's the story story we want to tell with that data. As I switched over into the machine learning world, I'm really taking the output from that sort of data science SDLC, right? Like the life cycle of them generating that data product. And I'm building models that not only operate on that data, but the machine learning framework is also able to refine itself based on the acquisition of more data. How accurate is that in the description?
It feels to me like it's backwards. Isn't there machine learning that creates the models that then the data science team uses to run the data through to create the data product? I was thinking of it backwards, the other direction. Or it's a circle.
Yeah, it can be both, actually, depending on exactly what you're trying to do, right? Because sometimes you have the data and you're just trying to tell a story, do some analysis, build some product out of the data. And it's just a matter of working with the data, right? You have to clean it, you have to do some transformation, right? You have to get it into the form that you need to use. But if there's no real barrier to doing that, then that's the data science task you're working on. And in that sense, it wouldn't necessarily be a machine learning problem, right? Because you're trying to do other things. But then, Kevin, you're also right. Sometimes maybe you want to build a product with this data, but it's missing something. It's not in the right format, right? You need to add information. You need to transform it in some relatively complicated way in order to make it usable, to answer some question, or actually, be ready to produce some product or be part of some product. And so then that's where you actually have to train a model to do whatever needs to happen to the data so that you can use it.
And then there's types of those models, right? So there is like you're running through billions of rows of transactions and you're doing like statistical things, looking for anomalies, looking for trends, looking for likelihoods and things like that. That's one type of model versus natural language processing models, which tend to be focused on text and sort of answering questions. I guess they're both answering questions, but
Yeah, just different types of questions. So if you're doing fraud detection, right, all the data is there, but kind of the whole point is you don't know where the fraud is. You can't just inspect the data. There's no way to plot it or visualize it that will show the fraud. Ultimately you need to train a model. And this is where the training comes in. You have to have examples of what is fraud and what isn't. You have to have the actual ML engineers who are building the models and figuring out what's the way to design the architecture of the model such that it performs well at this task. And then you train it. And the real value, the business value you're getting out of that is what the model adds, right? It goes through every row and tags it and says, this is fraud, this is not fraud. Without that extra addition, the data doesn't produce the value.
and if I remember my PowerPoint, I think at some point I was supposedly training people on machine learning models, which is a horrifying statement in retrospect. But if I remember, one of the things was a lot of these things, and I don't know if the large language models are this way. It sounds like we have no idea what the large language models are really doing, but they seem to work. But like some of them on that, like fraud detection is a good example of it really is just like hyper advanced pattern matching. Like it is just so smart beyond what a human's going to do unless the human spends 100 years doing it. But it is basically just like you told me that pattern A is bad and that pattern B is good. And so now I can infer against 100 million rows. And even to Andrew, I think you had an additional point is at some point there does seem to be certain types of models that can be trained in such a way to not only know this, that A is bad and B is good, but also the trend when C shows up, C is more likely to have A's happen 40 days later. Like there are additional like really complex things, but at the end that is still just hyper advanced pattern matching as far as I can tell in some of these types of models.
Yeah, I think that's a good example of traditional machine learning models, the ancient ones from 10, 15 years ago.
Right.
They really are just focused on identifying patterns that are really hard to see in any other way.
Right.
So for the engineering minds who think in components, when we talk about a model, that could actually be multiple models that collectively you say, hey, this is the ABC model, but it's actually really model A, model B, model C that complement or cascade, the data can cascade through. So when we talk about model, that can actually be multiple models. Is that accurate?
It can be, yes. It's kind of definitions at that point, right? So technically a model is one statistical entity, right? It's one way of trying to capture the relationships in the data. But like in a practical sense, in a business process sense, your model for fraud can be like multiple individual models all working together.
So has machine learning progressed to the point where there's almost like message routing patterns where the system is smart enough to know, hey, it's this type of data, I'm routing it to this machine learning model, or actually I'm routing it to this machine learning model. So we do have the beginnings of that network of decision, which is I want to go this route versus this route versus this route.
Is that in the model or is that the engineering wrapping those 12 models together?
Yeah, to be clear, I would think that's in the framework, but that exists today. Is that accurate?
In practice, yes. When you have very complicated systems that are doing a lot of different things, they're usually very intentionally engineered, and all the parts communicate together in very specific ways, right? So there's this process of building model pipelines and data processing pipelines, but that are very well defined and do all these different tasks.
But it is very much like it's a pipeline in which data is engineered. Like you could be writing C# code that is taking data, passing it into the black box of model A, getting some results, looking at the results back in C#, saying, oh, I got result A, hand it off to model number 2, versus I got result B, hand it off to model number 3. And like, as far as I can tell, like that kind of branching logic is not necessarily inherent to a quote unquote model. That is the engineering wrapping around a bunch of the models, or have models themselves gotten better at that pathing?
So you can actually have models making the decisions about what path
Okay,
you
cool.
traverse. So
Interesting.
yeah, that's a level of complexity that oftentimes you have to get to. Where it gets really weird is that's all true, right? Traditional machine learning, that absolutely still happens, and in practice, that's what you want to do because you need to understand the system, right? You need to control it and be able to separate the different components into different parts. When we're talking about generative models, like the big language models, so GPT-4 can take in, or Google Gemini can take in text, images, audio, whatever. As far as we know, they don't give all the details, but as far as we know, that is one model. It is doing everything.
Right.
All the data just goes in, it does whatever it does, and it gives the output.
And to be clear, are those models like, I don't think you could you give ChatGPT 4 your last 5 years of sales history and say find the examples of statistical model results that you would get out of like they seem like different frameworks, but how far has ChatGPT gotten on that?
So in practice, you can't because of that context window input size,
Sure.
right? They can only take so much data at any one time, but we're not sure that is a fundamental limitation.
Interesting. Huh.
Explain feature engineering for our listeners.
Okay, so for a traditional machine learning model, let's use the fraud example, right? That's a really good case. So you'll have a bunch of inputs trying to determine, like, is this credit card transaction fraudulent? So you have numerical data, like the amount of the charge, the date it was on. You have categorical data, right? What was the charge for? What vendor did it come from? What currency is it in? And those are probably let's stick with those two as an example, right? So two very important sources of data that you have in this question of trying to determine if it's fraudulent. Natively, those types of data don't work well together, right? You have numerical data and then text data. How do you figure out, which contributes to the model in which way? So ultimately, those are your features. Those are your inputs that you're giving to the model, but they need to be prepared and designed in such a way that they can contribute versus just being entirely separate ways to try to determine fraud. So that's the engineering of the features that has to happen. You need to figure out, I have text data, I need to get that into some format that works with numerical data.
No disrespect to that, but isn't that like a fancy name for data engineering?
In a lot of ways, feature engineering overlaps heavily with data engineering, yes.
Okay. All right. So it's a lot. You made it sound a lot less intimidating than what I thought it was going to be. So
Yes.
I appreciate that. Thank you.
Well, isn't that a question of where you want it to happen? Either you massage all of the data into a standard thing and then your features are all just ready to take some kind of standard data, or the feature engineering needs to understand, I'm going to sometimes get text, I'm going to sometimes get numbers. Is that the difference? Like where it happens?
It can be where it happens, but it's the decisions you're making about the engineering, right? So with the text, for example, let's say you're going to take one approach where you're just checking for certain words in the description, right? Certain vendors that you suspect are going to be more fraudulent. And so you're making a very intentional choice. Here's how I'm going to convert this text data into something I can use. A binary flag, yes or no, is this vendor present? That's one way of doing it. But there's lots of other ways of doing that as well. That's a choice you're making.
So similar to like how search engines strip out the non-words, right? Essentially, like the ands and the a's and things like that. Would that be considered feature engineering for like a language model where I'm like, well, look, I'm stripping out all of the gunk that I don't actually want to necessarily? I know this won't be the case for all LLMs, but would that be considered feature engineering at that point?
So that's one of the other interesting things with the advent of language models. You don't do that type of feature engineering anymore. You just give the model everything and it
Interesting.
will figure it out.
But it does sound like when you're doing stuff like, so if I'm understanding correctly, the model doesn't want to know Visa, MasterCard, Discover. You're going to say, I'm going to tell you 1, 2, or 3. Like, is it a data typing issue? It all needs to be be the same data type. And so you are literally getting down to parsing text into understanding how it all is numbers, basically.
Yeah, yeah. So it could be a
Interesting.
data typing issues, and even for the numerical stuff, right? So if you're looking at just at the absolute value of the transaction, you can have a 1 cent transaction or $100,000 transaction, right? That's a massive range. Do you want to normalize that in some way?
Hmm.
Do you want to better capture the range of the values that you might see? Again, that's a choice that you're making when you're doing the feature engineering.
Interesting.
So this question is a little earlier than I was going to ask, but do you as a data scientist are you excited by the future that is to go 110 miles an hour into the future, or do you feel like that obviously the other end of the scale is going in at 30 miles an hour, and then there's a happy medium with a compromise? How if you're in charge of AI rollout, how do you think we should proceed the future?
Yeah, this is a question I'm pretty sure every data scientist gets. So I'm gonna try to be somewhat measured in my response. It's hard to tell, honestly. Mostly because I'm in it, right? That's my day to day. That's the work that I'm doing, and so it's really hard to like pull myself out and try to view things more objectively. When I'm doing the work, it feels nice, right? I have all these great models. It's a lot easier. I can just pull out a model and it will do most of what I need it to do. And when it doesn't, I fall back on older techniques. That's fine. Those still work. But yeah, it makes things a lot easier. But it's also so fast, right? Stuff that I was doing 2 years ago, I just don't do it anymore because I don't need to. The models are good enough where I can just use them. And that's insanely fast, period, for that kind of change to happen. When I try to look outside, seeing all the other areas where this technology is being applied, it does feel very much, like 110 miles an hour, right? It's all gas, no brakes. Again, day to day, that feels okay to me, but I'm probably not the person you should be asking, right? In other contexts, that's not really a good policy or a good way to proceed. It seems, anyways.
I only hear what I want to hear, and you heard it here first, folks. David is definitely behind me on the 110 miles an hour future. I love it.
At the same time, if it were to stop really quickly, I would probably be okay with that too.
Yeah.
I think that's an interesting. So, David, when we worked together, one of the things that we ran into was just the size of data required to train these models was so massive, and we never had that. We had legal restrictions why we could only use client A data with client A model, and we could never benefit from the fact that we just trained 10 other client models. And so, one of my questions for you was going to be: is the idea of finding training data sets, artificial training data sets, where you go and you create a bunch of fake documents that you're going to scan in. Is that even a thing that you all have to worry about most of the time now? Or is GPT gotten to the point, are these models gotten to the point that they've read the entire internet and they can synthesize everything for you at this point?
It's a really interesting question, and a lot of it is still undecided. So, there's lots of conversations, I'm assuming, right? This is certainly something that I experience, and I'm sure many other data scientists experience too. We have lots of conversations with legal counsel, right, in companies to try to figure out what should we be doing here, right? What's the way to proceed? A lot of the concerns around data usage are still totally present. In some ways, OpenAI and Anthropic and Google, they've made it easier for us because they just took all the data anyways, whether they
Right.
were allowed to or not, and trained all the models. And they give a nice little handy, we'll cover your legal liability. They say that right there when you use their API. Whether that holds up in court is a different question.
Right.
But they've taken on some of the risk, and so we still absolutely do have to think about it. And there still is sensitivity. I have a lot of respect for the people who work in like enterprise system architecture, or like designing how the data is stored and all of the required segregation of client A from client B. And sometimes when you show them a little diagram and there's that line leaving our VPC, right, going to some other company, they do not like that, for good reason, right, for very good reason. So yeah, it's still something we think about a lot.
So if I think of the examples, like we were in weird, minute legal terms of why this clause is a contractual obligation not to terminate for whatever, and like all of these weird things. Are the big LLMs, are they able to handle that, or do they still need? Is that still too specific? Google and OpenAI didn't have access to a billion legal contracts that were locked up behind, in filing cabinets physically or in PDF stores that they didn't have access to. Is this still a thing that you need to train your own custom model for these really niche scenarios?
So in some of them, I'm sure it still is, right?
Okay.
Because whatever niche area of, business you're in, there are even more areas that are even more niche, right? So it's
Right.
like a never-ending spiral. You can always find something that's new in that sense. But just the progress again in the last couple of years, it's surprising how much these models are capable of doing. Mostly because somehow I'm sure OpenAI and Google and all the others, they found some data, they paid to license it, or they took a somewhat sketchy legal position, just assumed they could train on it anyways if they had it.
Right.
And so yeah, a lot of that I think is already in the models, just the
Interesting.
sheer volume that they're using for the training data now.
Is the lineage of that clear to you all? Like, are there concerns? So again, I don't mean to harp on like our one example that's top of mind, but I know we got into weird situations of like we accidentally overtrained the model on California, New York, and Delaware contracts and didn't include the weirdness of like a Nevada contract. So like, do we know the lineage of these LLMs and whether or not we have broad enough context to handle the scenario, or are we going to find out 6 months in when this random use case comes through and the answers don't make any sense?
So that seems to be one of the key areas of contention right now. So broadly, what the industry is figuring out is that the data is really everything, unsurprisingly to some. I don't know if I could have
Right.
predicted that because I couldn't predict any of this, but the data matters immensely, and all of the big companies who have the highest performing models, they tell you nothing about the data that they use
Sure.
for various reasons. So no, in short, we don't know the lineage of the models. They won't tell us. They won't tell anyone. There are some, people who are trying to say they should be required to, right, legally required to share the lineage of the data that they use to train the models. Maybe that will happen at some point, right? It's a regulatory question again. That doesn't seem to be happening in the near future, though.
Right.
It's a weird situation though, right? Because it's almost like that's become the secret sauce. As data's become closer to becoming a product, now it's become a product that feeds these models. So data science makes more sense to me. Like when you think about the quality of that data and some of your techniques for, hey, we do something with our data that nobody else does, it seems to be a hard sell for those big companies then to say, hey, we're going to show the world our secret sauce of how we cleanse our data and prep our data better than everybody else. So that is an interesting challenge, right? Because then they're asking you to trust their data.
Yeah, and some people, New York Times, for example, they don't like that.
Right. Yeah. So in the cases where you do have something niche and you do need to train against a unique scenario that you don't think the large language models are doing, and yet you don't have I'd be curious, like what is the process of training the model? Are there statistical reasons? Like, what is the reason it doesn't seem to work when we want to train it on, we only have 100 messages and we need to have it figure out these really complex, people are asking questions or whatever it is. Why do you need a 10,000, 100,000, a million instances of this? What's the like scientific reason why the small training data sets aren't good enough?
Yeah. Well, caveat, of course, I'm not a researcher at OpenAI, who does this
Sure.
day in and day out. So this is mostly just what I'm reading from people who are in this space and, what the academic community is publishing. And perhaps the unsatisfying answer is we don't fully know, right? No one fully understands how these models work, the best ways to train them. There is a lot of attention on trying to figure out how do you do more with less data. There are some approaches that seem to work well and some that don't. But overall, I think the reason why it doesn't work is the way that these models are trained, it's brute force, right? I think some people could say it's very elegant the way it all happens to just work. Another framing is this is just pure brute force, right? You're getting in a ridiculously immense amount of data. Right? The latest models from Meta actually just came out like a week ago, 15 trillion tokens, right? Or about 7 trillion words, right, is what they
Good
trained.
grief. So it really is 100,000 monkeys typing at 100,000 typewriters, and we every once in a while accidentally get Shakespeare? Like, just statistically? Wow,
It's
that's
in
crazy.
in some ways, yeah. I mean, and it's that amount of data and then tens of millions, potentially even hundreds of millions of dollars worth of compute to train the model.
Right.
So it seems to work, but
I'm also guessing it depends on the complexity, right? Because if you're talking about, I shouldn't diminish this because I'm not a machine learning guy, but if we're talking about anomaly detection and fraud detection, I feel like they were some of the simplest use cases that technology's technology's been going after for the last 5, 10 years, and they were probably some of the earliest models, I imagine, right? Because there's volume of data, and then your anomaly detection is these things are outside of some bound, right? That we've established. Is that fairly accurate?
I think that is a good example. Yeah. So, especially at the financial services companies, fraud detection has been a huge part and a great example of, traditional machine learning for decades. And it still is.
And that was sort of my question is like, there's a difference between, an LLM versus, I don't know what a BERT model is versus a transformer model versus a classification model, but there does seem to be like degrees of the complexity of the actual model template type, whatever we call that. And so those might be able to be less training required, less data required, or maybe not. It's not clear.
In some ways, there can actually be more data required, but they're just a lot cheaper to
Hmm.
run. Right. So
Okay,
some of
sure.
these bigger language models, they're very large. They're expensive to run.
Sure. So in that situation, I think one of the things, don't you run? So I used to do a thing where we generated fake data so we could run QA and testing of a software platform, and the data generator was literally just a roll of the dice. So if it was the random number was 5, we stuck in subject line A. If the roll of the number was 2, we stuck in a different subject line. Like we stuck fake data into these things, but it was truly random, and that was good for our testing. We just knew we would encounter random scenarios. I would be curious, kind of the example earlier I was thinking through that we ran into of like New York, Connecticut, and Delaware were like always the type of contracts we ran into. So if you were randomly generating one of the 50 states, then actually aren't you training your model incorrectly? Aren't you training your model to expect 1/50th of the time to get a North Dakota contract? And so your data set generation has to be aware of the type of thing you're going to encounter in the real world, and your random data generator has to also over index towards California, New York, and Delaware. So like the training data set that you create artificially also is a complex process, and that is its own engineering effort, basically.
Yeah, that's absolutely true. So whether you're working with, actual real data, but you always have to filter it down and transform it, right, and clean it up. So in a lot of ways, it's not raw data at that point anymore, right? It's a data set that you're creating.
Right.
How you balance the data seems to matter a lot because of exactly the points that you're making. If you don't balance it correctly, the model will start to learn associations that are problematic later on. And then synthetic data generation, that's actually still a big area, and language models make it easier in a lot of ways, right? It can produce a lot of really interesting data, but you have to be even more careful there, right? Because it will learn to produce certain types of data, and then it will just want to continue producing that same type of data unless you're
Sure.
very careful about trying to control the generation so you get the kind of diversity that you need.
Interesting.
It's fascinating, right? Because there's almost a fascination for me as somebody who's like wants to break the system, that even the bad data may unravel anomalies that are beneficial for a business, right? So you obviously want the good data to be telling the story, but I'm sure there's been times when you put bad data in there and said, wow, like who realized, who would have known that this inadequate data that we sent in there either exposed problems with the model or taught you something about the business. So there's almost an elegance to having that versatility, I imagine, like for different types of data to tell different stories.
Is that true, or does the bad data just make an even worse model?
I think it depends on the purpose of the model, right? So
Yeah.
if your model needs to deal with like transcripts or chat sessions, right? Those have they're not particularly clean for good reasons, and
Right.
you actually need to train that into the model so it has an understanding of what that looks like. If you're a social media company, right, who's doing content moderation, which is a very difficult job, a lot of
Right.
credit to the people working in that space. There's been some interesting work. I think this might have been from the academic community showing you have to train your model on some pretty toxic data for it to be a good content moderator. If you don't expose it to that, it won't be as good.
I guess I was thinking about people speaking English in a second language too, right? Like I
Right.
want my model to still work, but I've also got to take into account that if you're my father-in-law, flip a couple of English words and it makes perfect sense to him, and you want it to make sense to the. It really is fascinating.
We've talked about on past episodes, like my constant concern about the sort of prototypical computer vision example of they forgot to include African Americans in the original training data set, and so we couldn't see black people on AI models for a while. Like you gotta figure out like what is the bias that's going into those training data sets, even if they're pulled from real world examples or they're synthetic. If you wanted to go and train on internet moderation, pulling 4chan and 8chan as your sources is going to give you a different model result than pulling Facebook and Twitter. Twitter is closer to 4chan these days, but yeah, it's those data sets are going to influence the output you're going to get because of what the input was.
I'm interested in that then. So as with data science and machine learning, with demographics being sensitive, right? If I'm a marketing company and do I want to take those demographic percentages into account if I'm in Massachusetts versus my demographics of being in Southern California? Like, has it got to that point yet where the data sets that I'm training in Southern or the system just knows, like, hey, if I'm in Southern California, I might have a higher South American population. Same with South Florida. So it's weird because we don't want the bias, but then there are situations where for like marketing and segmentation, the bias is probably wanted and needed, right? Because that's why I see Spanish commercials in South Florida on TV, but you don't necessarily see them in Massachusetts. So
Well, and it's kind of like you don't want to be the guy who's saying like, oh, I don't see color. It's like, no, you need to actually see color to understand the systemic things that are going on.
Yeah.
You do need to actually make sure that your data set is incorporating those kinds of things
Yeah.
and making a conscious choice about that. So the bias is in the other direction. The bias is to say, I'm not going to make the conscious choice and just accidentally, by taking a sampling of the random data from across the country, my data set's going to have whatever it is, 60% white faces. And yet I'm trying to sell to, major urban centers south of, Colorado. Therefore, that's not going to be a good training data set. So the bias is getting rid of and understanding what you need to index towards.
yeah, I imagine a lot of companies are going to get it wrong.
Yes.
Right.
Let me ask you a controversial question, David.
Okay.
Gird yourself.
As a Brit, there are some things that are hard to move, hard to update in America, and which is odd because I think when I look at things like Sarbanes-Oxley and GDPR, as Europeans, we tend to take those things much more seriously than in the US has historically. But when it comes to privacy and what everyday people are willing to allow happen with that data, it seems to the core of Americans where it's like, we don't want to be spied on. Like you can't put a million CCTV cameras in front of Americans and then expect them to be okay with it. Do you see that? Do you see AI actually influencing that change in America where there becomes such an appetite for more data, audio, video, and more data? Do you see that immovable mountain moving around privacy?
It's a very complicated question. And I might differ a bit in the framing because on the one hand, yes, you could say that Americans don't like that kind of privacy control by the government, but in general, we're very quick to give it to companies. And oftentimes that's just a revolving door because then, the government can go and buy it from the companies or get it in some other way. So I'm not actually sure, whether there in practice there is a big difference. When Google is training their models, they're absolutely using YouTube data. Maybe they're using Gmail. I don't know. Actually, I've never read the terms and service of my Gmail account, even though I've had it for 18 years or however long it's been.
Right.
So they might be using it already. And if there's more appetite to do so, I wouldn't be surprised. And even just looking at myself, if the deal is you can continue using these services for free as long as you give us your data, I've made that choice in the past and I gave my data.
And I think in 1 week, I don't think it's in the same bill, but within 1 week, we did pass a law that both banned TikTok and expanded the ability for the Treasury Department to snoop and spy on you and for the NSA to get access to all of your data. So Americans kind of both simultaneously complain about that stuff, but then it's been an Orwellian access to your data since 2003, since the Patriot Act went through and fully reformed how you can do warrantless wiretapping and full access. They can go to any company now and tell you, you're going to give us all of the private data you have about this person because of you're on a college campus complaining about the, situation in the Middle East and therefore you're a terrorist and we're going to, be able to read all of your emails. Like it is both. Americans are having their cake and eating it too in the wrong direction.
Yeah. Yeah, it's interesting. I mean, I think it's no secret my views on it. Like, I just want to feed the system data, so I'm all for. I
Yeah.
don't mind when the NSA does stuff like that because I'm like, hey, you don't want anyone to find out. Don't put it online. Don't say it out loud.
You're a straight white guy. It's the easiest world to live in when then you can let that happen. Yeah. All right, well, that's going to do it for us on this episode of Acceptance Criteria. Remember to download next week's episode for part 2 with David, where we talk about the expanding capabilities of low-code, no-code solutions and other tools that are lowering the barriers of entry for people to get into data science roles, as well as how important the collaboration between data science, product management, and engineering is becoming. If you like what you heard this week, maybe go and drop 5 stars on Apple Podcasts and leave us a nice review. And if you didn't like what you heard, remember the name of the podcast is Triple Click. Also, tell your friends if you like the show and that they should check it out. Some of the best podcasts out there go by word of mouth, and we'd much appreciate it. To read articles that we've written on similar topics to the ones we talk about here, head over to the blog at acceptancepod.com. You can also follow us on most apps. We're at AcceptancePod. We'll post links to show notes and any articles from the blog over there. We're also building a community on Reddit at r/acceptancecriteria and on Discord. You can find links to both in the show notes and on the blog. And I promise we'll be moderating the crap out of them to keep it a nice little slice of the internet. For now, I'm Kevin Thomas Euland, and you can find me on most apps at ktomasuland. That's ULLAND.
And I'm Andrew Greener. You can find me on most apps at Criteria Greener. That's GREINER. And this has been Acceptance Criteria. Thank you for listening, and we look forward to hearing from you.